morning children. Today we will be continuing with chapter 5 Euclids geometry with exercises as well as a few extra questions which will help you to write the answers when it is asked for the exam. Exercise 5.1. Question number 1. Which of the following statements are true and which of them are false? Give reasons for your answers. The first subdivision is only one line can pass. The first one is only one line can pass through a given point. That means you are given a point A. The question says that only one line can pass through this given point. Is it true or false? It is a false statement because if you take the point A, through A or passing through A, there can be infinite number of lines. Thus, the statement only one line can pass through a given point is false. Second one, there are infinite number of lines. There are infinite number of lines that can pass through two given points. This is quite contradiction to the axiom. The first axiom, what is the first axiom? First axiom says that there is only one line which passes from one point to another. So again, this is a false statement. You can mention the axiom that as per the axiom, there is only one line. A straight line may be drawn from any one point to another or given two distinct points. False. Given two distinct points, there can be only one line passing through them. So this answer is also false. The third subdivision is a terminated line can be produced indefinitely on both sides. A terminated line. It is a true statement. It is in connection with the axiom. Number 4. If two circles are equal, then their radii are equal. Number 4 also, it is a true statement. The axiom says that two things which coincide with one another are equal to one another. You can give the reason as two things which are coinciding with one another are equal to one another. Here also you can mention the axiom, the same as an axiom. The fifth one, if AB is equal to PQ, if AB is equal to PQ, PQ is equal to XY, therefore AB is equal to XY. That is also a true statement as the axiom. If two things are equal to the same quantity, they are equal to one another. So the axioms need to be by hearted so that when it is asked as true or false, you can write true as well as support your answer with the axiom. Before explaining question number 2, let me explain to you what is the meaning of consistent axioms. You know, axioms are accepted fact or universal truth which doesn't require a proof. So, when the axioms are set, we normally say that the axioms should be consistent. That means each axiom is used under specific situation. That is, by the help of one of the axioms, you cannot prove what is said in the other axiom is false. the definition of consistent axiom is, if it is impossible to deduce from these axioms a statement that contradicts any other axiom. Normally, axioms are consistent. That is, they occur under different situations, or each axiom will be true to itself. Each of the axiom will be true to itself. That is the concept. So, the definitions can be defined. Parallel lines. In the beginning itself, we have discussed about the undefined terms as point, line, plane. Now, any of these definitions, if they have new words, we have to consider it as undefined terms. The first definition of parallel lines, try to make the definition using the undefined terms already we have. Parallel lines can be defined as lines in a plane which do not intersect or meet, however far you extend them on both sides, or however far you extend them indefinitely. In that, the word intersect may be defined again. Second definition of perpendicular lines. Two lines, perpendicular lines can be taken on only for two lines. Two lines in a plane which intersect each other at 90 degrees or at right angles. Even though they mentioned the term as equal right angles or equal anywhere, one of the axiom has been discussed. The term angles can be discussed again. Line segment. We have an axiom saying that a terminated line can be extended on both sides. What is the meaning of terminated line is actually line segment. So we can make the definition as a line with 2 points as endpoints and all the other points in the middle of these points, or all the other points lying between these two endpoints. That can be considered as a definition for line segment. The fourth definition should be radius. It's already mentioned that in the axiom or postulate as any circle can be drawn with a center and any radius. So, radius means it's a line segment joining a fixed point, can be center with a fixed distance joining the center to any point on the circle. The word center may be defined. The fifth definition should be given as square. You can also start as a quadrilateral with all sides equal and angles equal to right angles, or we can start as a rectangle with all sides equal, because already the rectangle has equal angles, is called a square. Maybe the word rectangle can be defined. So this is the way you answer question number 2. Question number 3. Consider two postulates given below. The postulates have been highlighted, which shows that two accepted results given below. Given any two distinct points A and B, by the axiom, what do you know? There is only one line which joins these 2 points. It is already mentioned in an axiom. There exists a third point C which is in between A and B. That is, they are telling that there is a point C which exists between A and B. It is a true statement, and so it is that postulate is accepted. What is the second postulate? given any two distinct points A and B, given any two distinct points A and B, there exist at least 3 points that are not on the same line. Okay, there are many points on this line. They are asking you, they are giving you an accepted fact that there are 3 points which do not lie on this line. Okay, so this is also one of a true statement. That means there can be many points which are not on the line. They are telling there can be at least 3 points which are not on the line. So this is also one of the postulate which can be accepted. Now they are asking you, do these postulates contain any undefined term? The already undefined term is point and line. The undefined terms are point is there and line is there. Then the next one, are these postulates consistent? Do they follow Euclid's postulate? Are these postulates consistent? They are consistent because the two postulates which are given to you, both are true statements, both are true to itself, and it is not connected. They are used in two different situations. They are consistent because they are used in two different situations, as well as both axioms are true to itself. That means both the axioms are true by themselves. Now explain, do they follow Euclid's postulate? No, it is not Euclid's postulate, but they follow Euclid's axiom. Both these postulates do not follow Euclid's postulate, but axiom 5.1, given two distinct points, there is a unique line that passes through them. It is following axiom 5.1 in page 81. Question number 4. If a point C lies between 2 points A and B, if 2 points are given to you, immediately by axiom, there is definitely one line passing through them. If a point C lies between the 2 points such that AC and BC are equal, that means it is given that AC and BC are equal. What you are supposed to prove is AC is equal to prove is AC is equal to half AB. How do you write the answer and how do you write the axiom? Now, proof. Since by Euclid's axiom, there is only unique line joining two distinct points A and B. That is, line AB is confirmed. Now, AC is equal to BC given. It is already given in the proof. By another axiom, equal quantities can be added to both sides. So you can write here, adding AC to both sides, AC plus AC is equal to BC plus AC, adding equal things to both sides make the whole equal. The axiom has to be mentioned. Now, AC plus AC is 2AC and BC plus AC is AB. Half of quantities on mixed sides, that is AC is equal to half AB. So, by pure applications of the axiom in each step, we are proving that AC is equal to half AB. Question 5 is asking you one more clarification from here, as in question 4, point C is called the midpoint of the line segment AB. Prove that every line segment has one and only one midpoint. So, given that C is a midpoint. C is the midpoint. So, what is to prove is there is only one and only one midpoint. That is, C is the only midpoint possible. Proof. Let us suppose that C dash is a midpoint of AB. Let us suppose that let C dash be the midpoint of AB. So, since C is the midpoint, C is the midpoint of AB given, therefore AC is equal to half AB, as we have proved in question number 4. If C dash is a midpoint, also AC dash is equal to half AB by our assumption. That means we assumed that C dash is the midpoint. From 1 and 2, things which are equal to each other are equal among themselves. That is, AC and AC dash has become equal. AC part and AC dash part are equal, we could prove. This is impossible unless C and C dash coincide, or it is only one point. Both C and C dash represent a single point. From 1 and 2, AC equal to AC dash proves that C and C dash coincide. That means they are only one point, or there is one and only one midpoint for a line segment. This all can be proved with the help of this axioms. Number 6, it's given that AC equal to BD. The length AC and length BD are equal. What you have to prove is the length of AD is equal to BC. Very clearly you can say that AC as well as BD have a common length of CD. If you can subtract the common length from both the sides, by the axiom, things which are subtracted from both sides, the remainders are equal. So, proof starts as AC equal to BD, subtracting CD from both sides. AC minus CD is the same as BD minus CD, things which subtracted from equal things which subtracted from both sides make the remainder also equal. Remainder also equal. AC minus CD is giving you AD and BD minus CD is giving you BC. The last question in this exercise, why is axiom 5 in the list of Euclid's axioms considered as universal truth. The axiom 5 says that the whole is greater than the part. This particular axiom is not only applicable with mathematics, it is applicable with everything in the whole world. That is, it is true for anything in any part of the world. Since this is true for anything in any part of the world, you can say that it is a universal truth. Any example you take, we can see that a part is always smaller than the whole, or whole is bigger than a part. Euclid's fifth postulate played a very significant role in maths because the postulate said if two lines are intersected by another line in such a way that the angles on the same side of this line, the total of the angle is less than 180, then only the lines when extended will intersect at a point. Or by this postulate, it has been made very clear that if two lines are cut by another line in such a way, if the total of the angle is 180, then the lines, however far you extend them, they will not meet, and from there the definition of parallel lines also came into existence. There were so many versions of this fifth postulate. One of the very important postulate is called PlayFair axiom. PlayFair's axiom given by Scottish mathematician John Playfair. What was his version is? His version is, for every given line L, there can be a point P outside, and even if you draw many lines through this point P, even if you draw many lines, there can be only one line which is exactly parallel to this line. Once again, given a line L and a point P outside it, there can be only one line through P parallel to L, even though there are many lines possible through the point P. This was Playfair's axiom. This is another version of the fifth postulate. It can also be said as two distinct intersecting lines cannot be parallel to the same line. That means two lines, if they intersect, they cannot be parallel to the same line. If you take two intersecting lines, this line can be parallel to a line here, or this line can be parallel to a line here, but they cannot be parallel to the same line. Both these lines cannot be parallel here, or both these lines cannot be parallel here. That is, there can be only one line parallel to a given line through a given point outside the line. That is the different way of fifth postulate by Playfair, the Scottish mathematician. The definition or the PlayFair axiom is stated as, for every line L and for every point P not lying on L, there exists a unique line M parallel to L and passing through P. The figure demonstration or illustration shows that you can see that out of all the lines passing through P, the only one line M can be seen parallel to L, which shows that the perpendicular distance between these two lines is always 90 degree. Any point on this line and here line, the perpendicular distance will always, the perpendicular angle will be 90 degree. That is the meaning of this PlayFair axiom. The lesson is completed and the worked out examples I will explain so that you will understand how to write the problems for the exam. Page 83, example 1. Page 83, example 1. If A, B, C are 3 points on a line and B lies between A and C. If very clearly they said A, B, C are 3 points and the points in such a way that B lies between A and C, what you have to prove is AB length plus BC length is AC length. To prove is AB plus BC is equal to AC. Here, what you can see is AC length coincides with AB plus BC. AB plus BC. Also, Euclids axiom says that things which coincide, that means AC coincides with AB plus BC, and by the axiom, things which coincides with equal quantity will be with things which coincides with one another are equal to one another, which shows that AC coincides with AB plus BC means AC is equal to AB plus BC. The next example is prove that an equilateral triangle can be constructed on any given line segment. The second example is, an equilateral triangle can be constructed. You are given a line segment AB. There is an axiom saying that you can draw circle with any radius and any center. Let us take the center as A with center A, radius AB, with center A and radius AB, you can draw a circle or an arc. Similarly, with center B and radius AB, you can draw another circle. These two will meet at a point C. If you join AC and BC, it will be a triangle. And how do you prove that AB, BC and AC are equal is AB and AC are equal because radius is equal. Similarly, AB and BC are equal because the same radius. Thus, triangle ABC is equilateral. So you can study both the examples, worked out examples as in the textbook, the explanation I have given you.